So I said to you that with LEDs, they don't act like usual loads, and I'm going to show you that now. So here, bear in mind we've done our calculations. What would happen if I changed the resistance of 140 ohms to something less or more? What would happen if I changed it to 70 ohms? Well, if I change the resistance of this to 70 ohms, what would happen is that the drop across the variable resistor would be half of the drop across the whole lot, which would be 6.2 volts. So effectively, if I was to do that, I'd have a drop of 3.1 volts across the resistor, and I'd have a drop of 3.1 volts across the LED. But if I change that and I had a drop of that across the LED, it would actually draw more current. And if I draw more current, it'll blow the LED, but it would get brighter for a few moments. So anyway, what I'm going to do now is I'm going to drop this down to allow a lower resistance in this resistor here, but this will also cause a higher voltage drop across the LED, which will burn it out. Anyway, so let's see what happens. Less resistance, okay, less resistance. It's getting very bright now, and now it's starting to go an orange colour. We're drawing around about 130 milliamps now, and now it's starting to die. It's going like a reddy orange colour. So let me just check the voltage drop across it now, and I can tell you straight away that it's not a healthy voltage drop. Let's see what it's dropping. Oh yeah, there you go. So there's 5.5 volts across the LED now. 5.6, yeah, which means there'd be 0.5 volts dropped across the variable resistor. Maybe I just knocked it or something. Alright, so the LED is not looking healthy. Let's go a bit further. So we're going to, if I drop the resistance here to 0 ohms, then this means that the voltage drop will be entirely across the LED, which will completely destroy it. So right now, I don't know if you can see, but the LED is like an orangey red colour. And now I'm going to drop it a bit more, and it will burn it out. So now the voltage drop is entirely over the LED. This is 0 ohms, and it's not looking healthy at all. You see? It's not looking healthy. Alright, so I hope you enjoyed the video. So what we've done today is we've done a bit more messing about with Ohm's law, which is here. We've used it to calculate one or two various other different things, like how to calculate a voltage drop so that we can cause a drop and therefore leave something with an exact amount of voltage. And we've been able to manipulate these two as well. And of course, now you know that you can actually manipulate these two using these two and whatever else. They all work together. So that's Ohm's law. So yeah, I hope you enjoyed it and I hope you learned something from it. There's one more thing I'll point out though. So we've basically manipulated the voltage of an LED, the forward voltage, the ideal voltage which an LED needs, from an input source which is greater than the ideal voltage. We've dropped some voltage across here and therefore protected the LED. So some people will think, in fact I used to think, alright, well that's ideal. So if I need 6 volts in the near future and I've got a 12 volt voltage source, I can simply put a resistor in to drop the voltage and therefore leave my circuit with exactly 6 volts or whatever. And you can do that, but you've got to be very mindful. This is not appropriate for situations where a current draw is over a certain amount of amperage. And the reason for that is because, let's bring this back over here. Let's say you did have a circuit and it was 12 volts and you wanted you only wanted 6 volts on a particular section of the circuit. Well, what would happen? You'd have your resistances here, so whatever the resistance of your circuit is, and you'd input another resistance here to cause a voltage drop, etc. But if your circuit was drawing 1 amp, the 1 amp would flow through this resistor too. And what would happen if you drew 1 amp and 6 volts through this? Well, you'd be drawing 6 watts through. 6 watts would kill it; it would burn it. So yeah, it's not it's not a general purpose way to power things. It's just something interesting for experimenting with. But anyway, I hope you enjoyed the video and I hope you learned something from it. And thanks for watching. Bye.